We are in direct live, so welcome everyone for this 5th episode of our training web series dedicated to immersive learning. So, a short turn of the speakers. So, myself on the right, I am Nicolas Beaube. I have two main roles over training at LGM. The first one is that I'm LGM Academy Manager, which provides our business courses, and the other role is that I'm Digital Technical Manager for the training. This is why I'm here today.
Hello, I'm Julien Bazire. I'm a multimedia engineer, and I'm in charge of conception and production of augmented reality project and virtual reality project in LGM Digital.
So the tool that we are using today is called Livestorm, and you have on your right chat window, and just on the right a question window. So please feel free to write everything you want except for insults in the chats, and all of your questions in the dedicated window. Please be explicit so that at the end, when we will get one after one the question, we will not ask for further information over the questions. So, a short introduction. So we are at the 5th episode just there. There will be two coming episodes, one over methods that we have developed to produce fastly and tailored digital modules. And then we will delve in the 7th episode over the implementation and evaluation of the ADDIE process. And we will get a few links with the last episodes of customization ahead, and also short links with the second episode, which has dealt with pedagogical engineering, and more specifically to the training plan, which makes the specification of the training needs. So I talk about the ADDIE methodology. So here is this methodology. The analysis and design phases are covering what is called the pedagogical engineering. At the end of the design, we have a deliverable which is called the training plan, and which specificates all the training pedagogical means that has to be developed to cover the learning objective of the training plan. The development phase is, of course, the phase in which we are developing all the training material required. So this is where we are for this webinar of immersive learning. And then we will have the implementation phase in which we are playing the courses, and the evaluation phase in which we are both evaluating the knowledge acquired by the learners and evaluating the training courses itself. So here is a summary of our today's presentation. So first, Julien will get a few information about the immersive learning. Then we will get through the three big types of pedagogical means which are covering the immersive learning, and we will make a short conclusion and answering the question.
So when we talk about immersion, we have two approaches to realize it. The first one is to bring the user inside a virtual environment to recreate the places where you have to do some maintenance,
practical operation.
Some practical operation. Thank you. And we recreate this environment to image the user and recreate some practice sense. The second method is to bring some virtual element and bring it in the user reality. So to enhance some real object and to link the data of the formation to the real object of the formation.
So we have the three main types that have been written in the summary. what is called virtual tour, which is virtual reality but pre-calculated. We have real-time 3D virtual reality, and we have augmented reality that is over there. So when going through all the lectures, there is often an idea that immersive learning is pedagogically more effective. So we have getting through all these papers, white books, and of course using our feedbacks to give you the information related to this better efficiency of immersive learning devices. So first, when using virtual simulation, immersive situation, the immersion effects create more proximity, a better identification between the virtual simulation and the actual simulation, well, the actual environment in which the knowledge is going to be applied. So this proximity provides, of course, a better engagement and a stronger attention because, of course, of the immersion aspects of the modules. Then we'll have more realistic situation and also more repeatable situation because these devices are numerical and also cannot be played back the time you want. Here you can see the Ebbinghaus forgetting curve, which says that if you want the knowledge to be retained with a good rate, we often talk about 80 to 90%, you have to make 1, 2, 3, up to 4 repetitions to have this good level of retention of information. So of course, having repeatable situation is quite effective when dealing with the objective of retaining information. Another advantage is that we can make practical practical learning situation. And when we look at the learning pyramid of the retention rates, the practical situation are in blue there, 75%. The only one which is better is teaching itself. But of course, it's quite difficult when you are when you don't know the subjects of the topic to be trained. And you have also the right to make mistakes, the freedom to make mistakes. And we know today that error is a very condition of learning because learning efficiently is based on the destruction and on the building back of the links between the neurons. And this destruction is made by making mistakes. Finally, the last pillar of this justification is that the immersive learning devices have a freedom to script scenarios, and of course you have an increased control over pedagogy, meaning that you can, during a simulation when you are a teacher, move some parameters which will have an impact for the learner in the simulation, and you also have the ability to gather the information of the sessions that has been played, the simulations that has been played, to make an improvement, because you are going to see that, for example, in the third step of your Mentos procedure in virtual reality, you have very high rates of errors, and then you will get deeper in the training of this third step, for example. So once we have been through this immersive learning general aspects, we invite you to get through the 3 main pedagogical means which compose the immersive learning, starting from the augmented reality. So the major use cases are the following. The first one is the operation supports. So you have 4 use cases when dealing with operation support. The philosophy is the following, is that when you use augmented reality when being in operation, you provide to an operator contextual information which reduces the complexity of the information. For example, you will know exactly what screws you have to remove, what torque you have to use to for which screw, and of course it helps both in terms of complexity and in terms of rapidity. You also have sales and marketing experiences. It's quite interesting when you want to make your customers live an experience around your products. And finally, and what is our topic today, you have the training support. Mainly when you want to create and when you have to tackle with the handling and the discovery of a complex systems, we often have PowerPoints which are very, very heavy and hard to understand in terms of cognitive load. So having let's say a more accessible level of information with an immersive situation helps in this kind of situations. In terms of pedagogical analysis, thanks to the immersion, we have a very, very good attention capture and attention rate all over the simulation. Because for augmented reality and virtual reality, we have a large freedom in the code. There's a very, very flexible ability to create experimentation and freedoms of mistakes within the simulation, because the simulation are quite reactive through the action of the learner. And last, we have the ability to create engaging media by using gamification processes and hints. For example, making quizzes, playing on the multiplayer aspects helps, of course, having engaged learner in the simulation. So all the aspects create a strong emotion, and the emotion helps having a better memory anchoring, because the information goes directly to the long-term memory. In terms of benefits and limits, we have a very, very good pedagogical efficiency. We have a cost which is, of course, quite high, but it is directly linked with the fact that the complexity of production is also high in terms of skills required to produce, and of course, tools that are in the production chain. And we're going to have a few words of Julien on these two aspects.
So to produce this augmented reality project, the first step is the conception. We have to brainstorming and elaborate some storyboard. So in this storyboard, we define every ergonomics aspect of the simulation, and we can define too the different interaction for the learner, like the external media, the external knowledge to support the speech of the teacher. After defining all of these aspects, we can analyze and process the 3D model of our client. So we're gonna optimize it to use 3D model on device like tablet, and we're gonna texturing it to give the model a more realistic aspect, to be as close as possible to the real object. After this 3D model operation, we have to develop the tracking algorithm. So it's about put some 3D element in the user reality, and we develop this algorithm depending on the targeted device. After developing these two blocks, the 3D model and the algorithm for tracking, we can mix them up and obtain the first draft of the production. And we can iterate around this production to obtain the final product. So the tool we have access of is those one. For storyboarding, we have in the more common way, we have the PowerPoint and Excel, which are very common in industrial sector. To process the 3D model, we can use CATIA from Dassault system to get the model and do some optimization. And after, we use Pixies and 3ds Max to optimize it, make it lighter, and make it more realistic with texture, photo texture, and some material to do it. That's it. For the development part, we use it in the most of time Unity or Unreal Engine, because it allows to develop just one time to multiple platforms like iOS or Android or HoloLens, with the SDK, respectively ARK, Core, and the UWP platform for Microsoft. So we can go for the demonstration.
So as a demonstration, we have chosen, of course, a training use case. This training use case will deal with discovery of a complex system. This application has been built at the beginning to be in a private network using a Wi-Fi router and with a multiplayer aspects, meaning one teacher for approximately 8 to 10 learners, and we have interaction between them. For practical reasons here, we will just have the tablets of one learner or the teacher, because the two applications are quite similar. And the idea is to have a first simulation in which all the people will get in, and once all the people are in the simulation, then the trainer will have the ability to start the experience. Every learner will have the ability, as Julien is going to do, to put the 3D model, and then I let Julien follow its demonstration.
So, sorry in advance for little problem of connection. So as you can see, I am in a training factory in LGM Digital office, and sorry. And I can evolve around my 3D model based in the center of the room. Next, I can interact with this model. So to make it real size, for example. So it's a simplified 3D model, as you can see inside. And I can trigger some animation like this to obtain the main subject of the formation, which is the engine of the script. Just one moment. After obtaining this model, I can interact with it and trigger some animation. For example, this is a cycle of combustion inside the engine. We can put also some traditional media like video, interview, audio recording, and some textual information to support the teacher formation. So that's it.
So here is the first rope through the augmented reality module. So as I said at the beginning, you have a multiplayer aspect and more interaction between the teacher and the learners. And we also invite you to get in contact with us if you want more information with this aspect, which, as you can see, are quite difficult to show using, for example, a conference tool. So the second immersive pedagogical means that we invite you to discover is the virtual tour or 360 technology. So the definition is often related to Google Maps, and which is quite relevant because a virtual tour is basically having spots, 360 spots, having a path which is not necessarily linear, and the idea is to move from spot to spot following a specific path related to the knowledge or the information that you want to make your audience to acquire. The simulation are divided in three main types. The first one is the be prepared simulation to tackle with safety drills, to put immersive situation around a risky action or stressful situation. The second one is the getting under the skin simulation, in which we will have, for example, a briefing situation, meeting situation, customer relation to manage, or even using 360 video, we can have, for example, interviews with different people. And the last one is the being everywhere simulation, in which we can make field visit, discovery of how to reach places, learning expedition, or even onboarding scenarios or modules, and interactive documentaries making of backstages and communication. But the three main parts are more communication based. On the right, you have a few examples that we have made for several industries. In terms of pedagogical analysis, we find still a very good attention capture and retention rates because of the immersion provided by the devices. The experimentation is quite good also because you have the ability to create nonlinear scenarios, nonlinear paths, and of course it provides a feeling of freedom of evolving in unknown but very immersive situation, which helps having a good information retention rate. This is more complex, but still it's possible to have gamified modules, gamified interaction within the 360 technology. For example, adding quiz, adding badges to get when you have a certain action made in a certain order, and it provides a better engaging process within, let's say, embedded into the simulation. The freedom of mistakes is quite limited because when compared to augmented reality or virtual reality, known as real-time 3D simulation, you don't have, in this case, a direct reaction of the modules to the learner actions. Well, everything is pre-calculated, so you can create non-linear path, or you can free some gates when people answers in some way, so good or right at some quizzes, but this is quite limited. Finally, the emotion is quite good. The mark is more over 3/5 because you have quite an immersive situation. When you deal with unlinear path, you have really a freedom of discovery, and you can have some mechanism of gamification. So it provides a good, let's say, good mechanism to target the long-term memory when presenting the knowledge using this technology. In terms of benefits and limits, the pedagogical efficiency is good, very good compared to more classical pedagogical means, like PowerPoint, for example. The cost is also, well, it's more affordable than augmented reality, virtual reality, because the complexity of production is reduced. And once more, Julien will say a few words about these points.
So during the production process, the first step is the creation, like augmented reality. But in this case, we have less freedom than augmented reality for the user. So we have to predefine some point of view in our scenes or some places to create bubbles that are 360 degrees images of those places. So we have two methods to create those bubbles. The first one is real photos, real video at 360 degrees, which are take on site of the client spaces to present. And the second method is the 3D rendering. So we can recreate a whole environment and some animation, some characters inside of it to present the different points of the formation. When we have those bubbles, we can assemble it and add some interaction, some information relative to the formation, and generate the virtual tour in the last step. So to create those production, we have different software. For the storyboarding part, we have the most common PowerPoint and Excel. To real capture, we have different devices. The most common one is the Ricoh Theta, but you can use some hybrid camera to take 360 picture, or even some traditional camera with 2D pictures, and you can also assemble those pictures with photo stitching software, which can combine pictures and unroll them in a bubble. Once we have those bubbles, we can post-process it with Adobe Suite, for example, Photoshop, Lightroom, After Effects, etc. In case we don't have access to site, or we can't take picture of it, we can recreate it in 3D. So for that purpose, we use 3ds Max or Pixies and Substance to create some photorealistic texture. With those bubbles created, we can assemble it in some software dedicated to that, like Virtual Tour or the old Panetry. So we can go for the demonstration.
So we have chosen to keep the continuity for this first demonstration. So we'll get back to the EV Armored Vehicle, the augmented reality module. So here, this will be a 360 virtual tour based on 3D. Then we will leave the photos and we will get to the video with a 360 3D video simulation. And we will end with a virtual tour based on 2D classical photos made by, let's say, classical camera, a reflex from Canon, which has been assembled with the stitching methods that Julien just talked about, and which has been both used for training purposes and also to be embedded into a CMMS.
So the first demonstration is this one. All of this are recreated in 3D software. So you can, as you can see, we have the vehicle, and we can go around with some predefined point of view, like this. And we can interact with some content inside the virtual tool. So to increase the immersion of the user, we can create some animated 3D model like that. So I think you can hear it, but we had some sound to increase the immersion. As you can see, we just had, in this case, some character to animate it, but we can perfectly imagine some animation of tool, animation of a system inside of it. The next one is about real photo. So we have taken it with the canal and assembled it. So we add some hotspot to show some content and present the environment to the user.
Maybe you can make a zoom on a technical place to show the difference between, let's say, maybe some people that have already seen, for example, on Google Maps or other experience. Yet, even when zooming, we have very good quality of the photo. And this is mainly the difference when using a Ricoh data, for example, which will not provide this level of readiness of the information. Last point is that all these simulations are easily accessible because informatically there are HTML formats, so quite easy to spread. And there are also the ability to put it in a headset. Often when making it in a smartphone, for example, and then in a cardboard, which provides really a completely immersive situation in which we are totally in the situation. And I let Julien explain the last type of 360's immersive simulation.
The last type is about video, real video. We can show our products because we have to stay discreet about this with link to different programs. So I invite you to go to uptel.io, which have a very good example to this type of project with all real video in it. That's it for demonstration.
We are not stakeholders of Uptel, so you can go directly. There's no incentive from our side. So we are almost at the end of the path. The last pedagogical means is virtual reality. By virtual reality, we mean real-time 3D simulation. So you have, for example, a screenshot of some simulation with Julien sometimes in the screenshots. So the major use cases are the following. First, we have the validation assistance, mainly for the design departments when dealing with the design of the equipment, tools, and accessibility of the principal system. We have decision-making supports, mainly when we deal with industrialization phases, installation phases, when we have to simulate the flow, for example, of a new production chain, or even to accompany the change management when we move, for example, the production chain, or when we get to a new infrastructure. We have sales support experience. Of course, it's quite easy to understand that it's far easier to move a laptop with a headset, virtual reality headsets, when we want to make an experience around EV armored vehicle, an aircraft, or even nuclear plants, than, of course, taking with you the EV armored vehicle or the nuclear plants at the other side of the globe. And finally, and this is our topic today, we have the discovery and training matters, mainly for the use and the maintenance of complex systems. In terms of pedagogical analysis, well, we are very, very close to the analysis we've made for augmented reality, meaning that the immersion is very, very high. So the attention capture and attention retention rate is very high. Like augmented reality, the code is very flexible. So we have really the ability to create experimentation and freedom of mistakes with a simulation adjusting to all the action of the learner. And we have also the ability to create very engaging media when adding all the processes of gamification within the simulation. As a result, of course, the emotion is quite high, a very, very good identification, a very good immersion with very realistic scenarios, of course, results in having very good memorization and memory anchoring, because we get directly to the long term. In terms of benefits and limits, we have so very, very good pedagogical efficiency. We have a cost and a production complexity, which are, of course, quite complex. I just get to the pedagogical efficiency by saying, like augmented reality, this pedagogical efficiency is very, very good. When we deal with the relevant use cases, we cannot do augmented reality and virtual reality. So now I let Julien give you more information about the production process and the tool used for creating virtual reality modules.
So, like the other, the first one is the conception phase, the conception step. So we have to, for the real virtual reality, we have to prepare and predefine all reaction to the freedom of the user. I explain myself. In virtual reality, we're less directive than the other, so we let the user make mistakes, and we have to prepare some reaction to it. So in case we add some gamification aspect, it can be some malus or some bonus, some warning, or some points, maybe, to the simulation. So all of these aspects have to be prepared in advance of the production. For the production part, we divide it in 4 blocks. The first one is about the main system, so the subject of the formation, which have to be as close as possible to the practice. So we put very great importance at the photorealistic aspect, at the physical aspect of each part of the material, and we predefine and optimize it in this perspective. For the environment, we have to recreate it, so it's a big part of the simulation too. We can create a workshop for operators. We have to implement sounds. We have to implement effects to the tools, etc. We have to add some 3D characters too. So sometimes it's just for the environment, but it can be for some avatar. So it can be in case of a multiplayer simulation. It concerns the other learner, the teacher, the learner himself. So we have to prepare all those animation and those models of character. And the last block is about the development of the interaction and the animation, the trigger, etc. The gamification aspects too. So when we have those 4 blocks, we can assemble it and have the first level of draft in our application. We can add to it some post-processing and special effects to make the realistic aspect more close to reality, and increase the immersion of the user. To realize those applications, we have access to multiple tools. So for storyboarding, it's always the same. We choose PowerPoint or Excel to make the exchange easier with clients inside our teams. For the 3D aspects about modeling and optimizing the client data, we use CATIA from Dassault Systèmes, and for the realistic aspect, we use 3ds Max and Pixies to optimize model and make it lighter for the simulation. To publish the application and to develop it, we use Unity and Unreal Engine because we can develop just one time to multiple platforms. So it's a very good gain of time. We can go for demonstration.
So at the beginning, we have chosen to make two demonstrations, but when we look at the time, this is quite hard. So we'll focus on the one on the right. The use case, this training use case, will deal with the remove and replace procedure of the old tank, which is this equipment of the truck engine. So why do we have virtual simulation here? Because when this procedure has been played, well, there is some traps, and often there will be some broken pieces into this when dealing with this procedure, and of course it has hard consequences because as these pieces are let's say commanded, there is a very few stocks. The trucks have been immobilized because space hadn't been available. So here is the context of this simulation, and I let Julien getting more into the example of the simulation with the headsets on its head.
Can you hear me?
Yes.
So I'll launch the simulation. So, sorry. A little trouble.
So I make a few introduction on some mechanism that we are not going to see in the simulation here. At the beginning, the few things that we have seen before this technical issue, we have seen a menu that we have developed, which helps, in fact, the learner to have the choice of their simulation. On the left panel, we had difficulty levels, which are linked with several use cases. For example, easy is discovery, medium is practice, and hard is exam or before operation simulation. And I let Julien getting back to the simulation.
So as you can see, I'm inside a workshop with all recreated environment. So we have some 3D character animated. We have some gamification element like this clock, which measure the time passed to do the operation. And we have some equipment around me. So the main subject of the formation is this engine, and I can interact with it. So to help me, I have multiple panel. I have the step of the procedure one by one. I have my different tool to accomplish the procedure. I have some consumable, some product to use in the formation. I have the real procedure accessible inside the workshop, so the paper format. And I have finally some video to present the ergonomy of the simulation. So I show you how I can realize some step. I can interact with the 3D element and realize the different step of the procedure.
So in this simulation, as you have seen, the move has not to be made realistically, because when we have made the pedagogical analysis, well, we have seen that when the operator has his key on his hands, well, he already knows how to make the moves, and then the customers didn't want it to spend money in creating the real move because it was not useful, and it can create frustration when it hasn't been perfectly numerically done. A few more information about the simulation. So I told you about the difficulty levels. There are also profiles that have been created, which helps having information and feedbacks about the simulation. For example, all the results of the mistakes that has been done into a simulation are aggregated, which helps us to see what are the topics, what are the steps in which there are more difficulties to create more, let's say, more deeper training. We have also seen where help is consumed. So which step, which type of ergonomy has been more consulted, which helps us to create more, let's say, easy way. I mean, numerically, to create the interaction and to create and to do the actions. And today, we are also starting at adding artificial intelligence within simulation for creating adaptive simulation in which you are doing one step, you have a blink, and then resulting on the steps you've done so far, the system automatically gives you a situation which results in your today's difficulties. These are a few examples. We also have done multiplayer aspects in this simulation where the trainer is doing some elements. You have 8 to 10 learners which are also connected with an avatar, and they are looking at the manipulation done by the trainer. I think that's all, Julien. I don't know if you want to add something.
No, it's okay.
Okay. So we are almost at the end of this presentation. So here is a short coming back through the justification drivers. If you want more information, I invite you to get to the replay of the second episode in which you have the demonstration of this tool. Here I just get to the main drivers. So the reproducibility of the training, if you have practical knowledge, if the availability of the system is very low, if the task you are on which you are training your operators or your targeted audience are dangerous, and if the learner is in risky situation, and finally, if let's say there can be harm for the system on which you are doing your practice, then these are all drivers that have a positive impact on the choice of having immersive learning in your situation. One thing that we hadn't written there is also the expert availability. In our industry, we're often faced to situations where experts are lacking, and they are necessary to create and to manage the simulation. Well, not the simulation, the classes, sorry. And when we had immersive learning into the training, we are less expert dependent, which of course frees some time to the experts to create more, let's say, added value tasks. Here we have a more detailed example of a justification of VR module for maintenance. I will not get through the details, but you have 4 main phases. The first one is the criticity of the knowledge application. Second, you have the criticity to be well trained. Then you have the complexity to deploy efficient training session, for example, the system availability, the trainees and trainer availability, and the population receptiveness to digital. And when combine all these points with a score, you have at the end a mark which provides you information about the efforts you have to make. on your training mean to provide, let's say, the efficient way to retain information. In this case, we really need a critical, we have a critical knowledge which requires an exceptional effort on the training materials. And when we analyze this result, we have found that virtual reality was the best method. So when you are working with a company which is providing immersive learning devices, of course you can ask them to have this kind of methodology to help you to have your justification processes to be done. Last but not least is the ROI calculation. When dealing with training devices, it's not always easy, but it's very, very important to get an eye on the ROI. So here are the 4 steps, let's say theoretically, to get through the ROI calculation. First is having the cost of your training system, combining the cost of development and the hours spent in training by your people. Then you can estimate the cost of failure and malfunctions before you had your new training system. Then you can calculate the rate of improvement by comparing the previous situation without the immersive learning device, for example, and then after when you had it. And at the end, you can calculate the ROI when dealing let's say, the comparison between the 2 situations. When we take an example, so this is in French, but I will translate the main information. Here we have a lot of inputs with the hour rate of an operator, the charge, the load in terms of maintenance work. We have penalties in this case because this is a very critical component. We have the cost of spares when we do the procedure, either when we do it normally or when we have a malfunction, which of course generates another procedures. We have the cost of mistakes and other inputs, but the one which is important is the number of times this procedure is played a year, which is 12 in our case. Then we compare the 2 situations before having the VR module and after having the virtual reality module with all the costs. So the cost there, the cost due to mistakes, the cost due to man hours, the cost due to training, and the total cost. So here we will add the costs of the module to be developed, which have been around 3,000 euros, which provides this curve. The green is cost with VR, so we are almost to 40,000 euros when adding the cost of developing the VR module, and the cost without VR. And we have the balance points at approximately 2 years when we have, let's say, the balance of ROI. So here is a practical example of calculation of ROI. Another information of industries that are using immersive training, immersive learning for their business. For example, Airbus, which has reduced by half its inspection time using VR. Boeing has made the same using augmented reality. The medicine and surgery is more and more using this technology, not to get faster. This is a side effect. The main reason is to make practice and to do less and less mistakes. And you have, for example, Walmart, which has bought more than 15,000 Oculus Go to create virtual tour simulation to help customers improve their soft skills and their customers' relationship management. And there's a few examples that I have. So, as a conclusion, we have seen today what is immersive learning, what are the 3 main components in terms of training materials that are in this immersive learning, from augmented reality to virtual tour to virtual reality. So it's then we have switched to the justification process and to the ROI calculation. So next week you will have the quick and clean way process that we have developed to create digital training modules. And in 2 weeks, our last episodes that you'll never forget, which will deal with the implementation and evaluation phases of a training. And before that, we will answer all your questions. So as you are not so numerous, we will take the question of this morning, Julien, because we had a few questions. We had a few about the costs. The one question has been, in all the simulations that you've shown, what are the costs of developing the simulation? So the augmented reality module with the multiplayer function in a private network was roughly 10,000 euros. The virtual reality modules that you have seen at the end with the remove and replace procedure of the oil tank was approximately 20,000 euros. And the virtual tours, the idea of cost was approximately 5,000 euros for the real, the virtual tour based on real photos. It was approximately 10,000 euros for virtual tour based on 360 videos. Then we get to 10,000 to 15,000 euros when we did the virtual tour using 3D, and it was approximately 20,000 euros for the 360 video 3D module. For both for the virtual reality module and for the 3D virtual tours, what has a high fixed cost is the 3D processing, meaning that if you want 2 experiences based on models that has already been treated and processed, then the cost is divided approximately by 2. Do you want to add something on that point, Julien?
No. Like you said, when we develop the core, it's the most of part of the first price, and depending on the ad to do for the next version, it can really reduce the price. So when, for example, you just have to add an animation, it can be really low to add some content, to add some external media, for example, to add some interview inside of our production. So yeah, that's it.
We were also asked this morning if there were existing editors or company which were provided, let's say, more accessible way to produce virtual reality and augmented reality modules. So yes, we have put them on the right side in this webinar. For example, Vuforia, Diota, Ublim for augmented reality, or Diginext and Serious Factory for virtual reality. Well, the question when dealing with, do I want to get these editors, or do I want to rely on a company which will made let's say a tailored module using its own tool? It's mainly ROI calculation, because these editors and software have roughly an entry price of 50,000 euros. And then you have to take into account your own cost on developing on these editors. So if you just want to make 1 or 2 modules, well, it's quite difficult to have your ROI balance. But if you do, for example, 10 or 20 modules a year, then it begins to become very interesting to have this integrated editors to enable you to produce yourself your modules. Another question we had this morning.
Just to add to this point, to update some content in your simulation when this not concern the 3D model, or the interaction. If, for example, you have to update some content inside of the simulation, we can think of a solution to put the resources of the simulation on a server and do some request to this server. For the client, you just have to update the content on this server and don't have to modify the simulation, and the content inside the simulation will be modified too. So depending on the update and the modification to do inside the simulation, we can have some solution which don't require some specific knowledge of software.
Yeah, you're right. Yeah. So if you have this kind of question, don't hesitate to contact us. You have our mails. We will not ask you for money just to have this discussion. There is absolutely no problem. Another question was, and I take it for myself: did all the company provide justification methodologies to VR, AR, or virtual tour experiences? Sorry. Well, not every company will do it. The message that I wanted to convey was mainly for you to ask to these companies to have this justification analysis, because we have, of course, it's quite natural, several actors on the market that are focused on one technology or one tool, and they will, of course, try to bias the analysis so that it fits with what they are doing. So, well, it's an advice to have you really engaged in this first phase of analysis, so that you have really the good immersive learning device for your relevant training needs. There's often no need for training device sometimes, so please feel free either to contact us or to be very, very careful in this phase. A question for you, Julien, was what was your feedback of using augmented reality for training?
So for training, it's about the different feedback we have is about more the devices. For during operation, having a tablet is not very practical. So in short term, we use tablet and promote tablet to do some offline lesson, if I can say like this, just for teacher with some learner and without the object, the subject of the formation at disposition. But in a more long-term vision, we recommend the HoloLens and the future mixed reality headset to have more freedom and have the hands free for the operator and do some manipulation during the formation or the operation which are accompanying the augmented reality. So for the feedback, it's for the learner, it's really good to have more interactivity and more freedom to discover the model, because with the tablet, for example, they can feel free to turn around it, to go inside of it, for the example of the vehicle. And so this degree of freedom is really appreciated by the learners. And for the teacher is a good improvement too, because it's more representative to explain some functionalities, some features of the equipment, and to illustrate it more efficiently than a PowerPoint, for example. So it's more impactful, and more efficient to keep the knowledge after the formation.
Yeah, you're right. The two last questions. The first one that I take for myself is that I mentioned an embedded virtual tour into a CMMS, and the question was why, and how it has been done. Well, we have worked for maritime and naval contracts in which we had policemen inside the boats, and they had many cases in which they wanted to order some spares, and many cases they wanted to signal some failures, some technical facts, but they were absolutely not trained with the CMMS software. So the idea and the modules that we have developed was to create a module of contextual information in which the policemen were able to navigate through their boats using the virtual tour, which was quite easy, and they can click with their finger because it was on tablets on the point on which they wanted to order, for example, spares, or where they wanted to report technical facts, and then they had a direct link with the function in the CMMS. And the question for you, Julien, was we talk about 3D virtual tour. What are, let's say, the advantages? What are the use cases where using this 3D virtual tour is more efficient than a classical virtual tour based on normal photos?
The more common reason is an access problematic, an access issue, or a security issue. In fact, the real photo and video are more cheaper than the 3D creation of the environment. But in some case, like one of the demonstration I'll show you today, the visitors can access to the places presented in the virtual tour. The example is about the train, the animated one, where our client can't bring visitors anymore due to some security problematics, and to present their knowledge, their expertise, they have to put some and diffuse some media that show the same immersion, the same feeling to their client and collaborators. So it's a good platform to easily diffuse this knowledge, this aspect of their work, and the 3D aspect is the better way to enhance the presentation and to highlight the particular aspect of some device and some measure they do inside the train. So they choose the 3D aspects instead of the real photo.
Perfect. Well, we have get at the end of our presentation. So thank you for having followed this presentation. We have put on this slide a few more information for those who want to get deeper into the subjects. So there's a link of a replay of a webinar, but it's in French. Well, so it can be quite boring for those who are not familiar with French. There's also white books. So the two last ones are also available in English. These two, I'm not fully sure. The first one is quite interesting, but very, very accessible. The second one here is a bit more complex in terms of techniques, but of course more, let's say, more rich in terms of pedagogical information. Please, when you read these two white books, keep in mind that these two companies are selling also the products, so it's of course demand a few higher of you, and we wish you a very good day, and we wish this webinar has been interesting for you.
Thank you.
Have a good day.